Alright, 2-3. Deductive reasoning. We're going to do two things. First of all, we're going to show you how to use symbolic notation. And then we're going to talk about the difference between deductive and inductive reasoning. Symbolic notation. Symbolic notation is important because, look at this. I'm taking a math class, and last night, all this stuff right here, look at this stuff. This is all shorthand symbolic notation stuff. This one phrase right here, if you were to write what this means out in English, it would take like a page. So we use symbolic notation as shorthand to communicate whole sentences and ideas with just one symbol. So this guy right here, you see this little arrow right here? That's what we're going to learn today. That's where we're going to start. So conditional statements, it's if-then. They can be written using symbolic notation. Symbolic notation, this guy right here, we're going to use this. So let's say that P is going to take place of our hypothesis. Q is going to take place of our conclusion. And this arrow, if you read it, it reads implies. So here's an example. If the sun is out, then the weather is good. So your hypothesis is P. If the sun is out. Your conclusion, that must mean the weather is good. So we're going to write this conditional statement, if P, then Q. Or better yet, right here, P implies Q. So we're going to take, this is the general for any conditional statement. Hypothesis implies the conclusion. So are we good with that symbol right there? Everyone's got the arrow down? Now let's go to your next page. Let's look at this one. Let's talk about the converse. The converse, you just flip them. So if P then Q, all you do is switch your P and your Q. If this right here was our Q and this was your P, if the weather is good, that must mean the sun is out. And symbolically, it's pretty easy. If Q then P, you just switch them. Q implies P. Okay, biconditional. This is your if and only if. This is what we did yesterday. Biconditional statement. Remember how it's forwards and backwards? So we're going to do an arrow going both ways. So if P then Q, and if Q then P. So you kind of go forwards and backwards. So if it's got an arrow with go both directions, that's a biconditional. But most of the time you're going to see it like this. P if and only if Q. Okay, your next slide. Let's try it. So here's your phrase. Let's say P is going to be the value of x is -5 and Q is the absolute value of x is 5. So here's your symbolic notation. P implies Q. Write it in words. Try and write that in words. What did you get for A? If the value of x is -5, then the absolute value of x is 5. And then the converse. Q implies P. So it's going to start if, but then it's going to be if the absolute value of x is 5, then the value of x is -5. So C, this is what we worked on yesterday. Is this true and this true? Is the conditional statement and its converse? If you flip it, is it true? That's a biconditional statement. Biconditional is forwards and backwards. So which one is true and which one is false? Top one is true. This is true. So your original, your conditional statement is true. Why is this false? If it is ever false, you have to prove it with a counterexample. X could be 5. There you go. That's the proof that it's wrong. X could be 5. And if X is 5, then this is false. Alright. Let's look at okay, the inverse. We're only going to show you 2 symbols. The first one, Eddie, was your arrow. This one right here, circle it. What does that one mean? That's how you negate things. Do you remember negation for the inverse and the contrapositive? So Eddie, here's our original statement right here. If P then Q, P implies Q. If the car will start, then the battery is charged. The converse, you just flip it. If the battery is charged, then the car will start. But do you remember these inverse and the contrapositive? You have to throw the word not in there. And this word right here means not. So, not P implies not Q. If the car will not start, then the battery is not charged. And the same right here. So 2 symbols, you got them. This little tilde means negation, that means not. Okay, Eddie, this is for you. Keep in your notes. So you have a conditional, converse, contrapositive, inverse. You can refer to it. Let's try it, let's practice. Okay, here's your sentence. P is going to be this. P is, it's raining. And Q is, the soccer game is canceled. So your original statement is going to be P implies Q. Now, take that original statement and write the contrapositive. Do it 2 ways. The contrapositive in English, and then with your arrows and your tildes. And if you got to, look back at the slide before. So your original is this. If P then Q. If it is raining, then the soccer game is canceled. So that's where you're starting from. Now write the contrapositive. So symbolically, how do you write it symbolically? The negation. This is a little tilde. Tilde. Q. Arrow. Tilde. There you go. Symbolically, that's all you got to write. Now, English. What's the English? Give me your English. If the soccer game is not canceled, then it is not raining. Nice. How many of you guys got that? Okay, do the second one. Do it both ways. Do it symbolically and then do it in English. What's the inverse? Let's do symbolically. What's the inverse symbolically? Tilde. P. Arrow. Tilde. Alright. Now, what does that mean in English, though? If. That means not. So, if it is not raining, then the game is, that means not canceled. Alright. Okay, our very last thing we got to do. So we've done the symbolic notation. Now we got to tell you the difference between inductive and deductive reasoning. I want you to read this page. Everybody read through this once and then we'll talk about it.